Okay, let's start the session then. I'll admit whoever joins later. So, welcome to the first session, live session on control system D09 course. So, I would love to interact with you guys. So, if you have any doubt at any point of time, just raise your hand. There is a three, but like more option kind of. There you can raise your hand and interact with me, and I would love that because if I will, if only I will be speaking whole time, then it might get monotonous. So uh, I would love to have your questions and your feedbacks. So without wasting time, let's jump to the first question. Okay. uh, I request everyone to join before 6, around 5:55 or 58, so that in between there is no interruption. Okay. So, okay. Let's wait one more minute, then if someone else will join. Let's start the session. Okay. So the first question, you might have gone through all the lectures by Professor Ram, and this is a very simple question. It involves the concept of LTI system. Okay, let me take a look. LTI system. So, what is an LTI system? LTI system stands for linear time invariant. Just forget about the question right now. Just try to understand. I'll just briefly uh, try to remind you the concepts. Uh, Time invariance. So what happens is there are two important terms. One is linear and another is time invariance. So what does a linear system mean and what does a time invariant system mean? They are actually different, and here in the whole course we will be dealing with the linear and time invariant system, which is called the LTI system. So let me add just a plain paper so that it will be better. So what is a so I said that it's a linear system and a time invariant. Okay. So what does a linear system mean? Linear system means it supposed it to have two important properties. One is homogeneity, or you can say homogeneous, and another is superposition. So what does a homogeneous system mean? A homogeneous system means, like, let's assume our system to be like this is a system. I am writing as SYS. Suppose it has some input, this kind of block diagram you are gonna meet throughout the course, x of t, and the output is y of t. Okay, simple. What is the x of t? What is the y of t? We are not concerning right now. Just imagine there is a system. We give some input x and we get some output y. So, and what if I just multiply the input x with some scalar constant, some scalar a? Okay, then if I'm putting the input x of t, then definitely I'll be getting some output. Let's denote it as y dash of t. Okay, so if my y dash of t is exactly the same amount scaled, the a amount scaled, then we can say it is a homogeneous property is satisfied, because initially what I was giving x of t and I was getting y of t. Now what I did, I just multiplied the input with a scalar constant a and observe the output. If the output is exactly same amount amplified or scaled, then we can say it's a homogeneous. So one important aspect you must understand, this is a very important concept I want you guys to realize it, let us assume this is a uh, like this is x of t and this is y of t. Okay, so just assume this is x of t, this is a simple plot, and let's assume the if we sketch the line, it's like this. So can somebody say, is this system like I'm giving some x of t and getting some out y of t, is it linear or not? You can type in the chat. So I would be loving to interact with you guys. So yes or no. My question is, sorry, is it a linear system? I don't. Okay, Purushottam is saying yes. Nice. And anybody else? There are, I guess, 10, 8 students. Anyone else? It's all about guess. Like, if you will be correct or you will be wrong. Sorry. If you will be correct or you will be learning something. Okay? There is nothing wrong. So, I want everybody to participate. Just type yes or no. What do you think? Okay. Tom, Johnny is also. Okay. Balaji is also. It's a linear system. It follows both superposition and homogeneity as well. Okay. Okay. Now, let's find out whether it satisfies linear, like homogeneous and superposition. So you might find like the system here, we can say y of t is equal to some m x of t plus some c constant. This is the c part. Okay. So what we had understood, this is the system. We gave some input x of t and we got some output. What is the output? The output y of t is equal to m x of t plus c. Okay, let us scale it. Let the input be scaled above a amount of ax of t. Okay, so now what do you get? You get m into a x of t plus c. This is my y dash. Okay, what my superposition, sorry, homogeneous condition says, my y dash should have y dash of t a amount of m of x of t plus c, which is equal to a into m x of t plus ac. But what I got only c. Look at the like. I will use some other color. Okay, this term, the c and the ac, they are different. So although this plot looks linear, it is not a linear system. The plot is linear, the curve is not curvy or circular, but the system is not linear because of the presence of the C. So we can say this system is this system is not linear unless C is equal to 0. So if my C is equal to 0, then AC will be 0 and I'll be getting same M AX of t and A into MX of t. Understand? So there is a condition for if you try to plot a linear system x in the x-axis and y of t in the y-axis, the plot must pass through origin. Okay, everybody guessed it was a linear system, but try to understand the homogeneous condition is not being satisfied here. You can see we are getting m into plus c and we should get ac. Is it clear to everybody? Just type yes so that I can proceed forward. Okay, thank you, Balaji. Okay, so this was the homogeneous part. And what does the superposition part means? Superposition means if my system, this is my system, I am giving two different inputs. So let us assume I am giving some x1 of t and some x2 of t. Okay. And I am getting individually some y1 of t. I don't know what is y. Okay. And some y2 of t. This x1 of t and x2 of t need not to be dependent, like similar kind of. Like I can give some one step input, another as a impulse input. So when I add both of them, and x1 of t plus x2 of t, what I am getting? Let's assume same y dash of t. If my y dash of t is equal to same y1 of t plus y2 of t, then I can say it is a it satisfies the superposition. Okay. So now coming back to the initial question what we had. Okay. This is the problem number one which I was discussing. The system is given as y of t is equal to t into u of t. Okay. Let's draw a system, imaginary system. So what we are giving u of t, and what we are taking the out, it's t u of t. Correct. So instead of u of t, let's take u1 of t and u2 of t. Okay. So if I put u1 of t, then what I will get? T into u1 of t. And if I put u2 of t, then I will get t into u2 of t. And if I add both of them, add here. So what I will get? I'll get t u1 of t plus t u2 of t. Correct? So I can take t as common, u1 of t plus u2 of t. So whatever I am giving the input, and if I take u1 of t plus u2 of t as some x, capital X of t, then when I give the capital X of t to the system, I get output as t into capital X of t. So it's the same structure. So definitely this is a linear system, 100%. So let's remove this to non-linear. These are non-linear. Now comes whether it's a time varying or time invariant. So due to the presence of t in the output, this becomes a time variant system. Okay. Due to the lack of time, because the meeting will be ended in 1 hour, so I'm not explaining this. If you have some doubt, then you can mail me. So this question will be, this is a linear and time varying system. Okay, everyone clear? And if someone has some doubt, you can mail me at, I am typing my mail ID. So note it down, and if you have any problem, just mail me. Uh, if I am free and I am available, I will reply back to you definitely. Okay. Now let's come to the second question. I think the first question is clear to everyone. Okay. This is a similar type of question, but here that was a kind that didn't have any derivative kind of problem. Now our system is, it's a double derivative system. X double dot of t plus x of t into x dot of t plus x of t is equal to some input given. So this kind of system you will, like you will be getting latter part of the course. This is just take some kind of ordinary differential equation. Due to the presence of this term, the x of t, this whole system becomes nonlinear, because this is a time varying system. That's why. Otherwise, if instead of x of t there are some constants k, some constants belongs to some real number, then it would have been a linear system. Okay. Now this is a question I want you all to answer me. Okay. The complex function is singular. First, let's understand what is a singular means. Singular, singularity, or a function has some singular, that means the function is not defined at that point. Any function, like I am taking s1 by x minus a, this system is not defined at x is equal to a, because the plot, if we try to plot it, if this is my x and this is my y, which is 1 by x minus a, so like one advice I would like to give you all guys, when reading control system, don't try to mug up anything. Okay, try to visualize it. If it's very mathematical, this course is very mathematical, you don't need to mug up any equation. Okay, everything will be clear to you if you try to visualize it. So simply, if you plot it, this is the system. So what, at x is equal to some a, the system will be like going up at till infinity. So this system is not valid, not defined at x is equal to a. So can you guys solve this question and tell me the answer quickly in 2 minutes? Now it's 6:17, so around 6:18, 6:19. Quick, it's a very simple question. And okay, Pushottam is giving -3 and -2. Okay. Yes. Anybody has any other answer? Okay. Balaji is also typing s is equal to -2 and -3. Okay. I'll just solve it. So what happens? The denominator, when the denominator becomes 0, denominator, that at that point the system is, can be said it is not defined at that point. So when the denominator, what is the denominator? S square plus 5s plus 6 is equal to 0. Two two types of solving you can do. One, you can take it's such a quadratic equation. S is equal to -5 plus or minus b square minus 4ac. So 25 minus 24 divided by 2, you will get -2 -3 from that. Or you can do the partial fraction kind of thing. So s minus, you can directly check here, s minus s, this equation can be written as s plus 2 is equal to 0. So from this also you can get -3 and -2. Okay, it's clear. It's a very simple question. Okay, so what is next question is, what is the Laplace transform of e to the power -2t cos t? So okay, so first forget about this question. Okay, don't look at this question. Let me add another page. Okay, so I'll give you some concepts here. There is a, if the function is f of t and the Laplace transform of f of t is capital of Fs. You can take any notation. This is a very genuine conventional notation. That's why I'm taking. Then what happens if I add some e to the power -at f of t? Then what happens? My, in the whole Laplace f of, in the whole this expression, look here, s minus a is there, here s is there. Then what will the Laplace transform of this equation will be simply s plus. Okay, just like this is, this used to be for f of t, if it's s, if we multiply minus a t, then the minus a will be a plus here and it will be f of s. So just simple, uh, like I want you guys to be involved in this question. So let's assume like the unit step ut, which can be written as 1 for t greater than or equal to 0 and 0 for t less than 0. Its Laplace transform, Laplace of u of t is equal to Laplace of 1 if it's 1 by s. Okay, then can you tell me Laplace transform of e to the power minus at into ut? What is the Laplace transform of this? Sorry, I shouldn't give you this much hint. Okay, can anybody say? Just type in the chat. Okay, Tom has answered it. Okay, Tom and Purushottam, very good. It will simply 1 by s plus a. Okay, now let's come to a little difficult question. Our very, like, our kind of best friends for the course, sine and cos. Sine omega t. What is the Laplace transform of sine omega t and what is the Laplace transform of cos omega t? Anybody remember? It will be omega by s square plus omega square, and this is cos. For cos it will be s square plus omega square. So actually I get confused between sine and cos Laplace transform. So how, like, this term, like where it will be omega and where it will be cos. So it's a cheap trick what I remember, like cos ends with s, so the Laplace transform starts with s. जहां से खत्म हुआ वहां से start हुआ. Okay, so you can argue like sine starts with s, so no, like it's just my convention how I remember. Cos ends with s, cos, then that's why the numerator has s. So there is no rule like this, just this is for just remembering, otherwise I used to get confused. Okay, so these are the Laplace transform of sine and cos. So what will be the Laplace? What will be the Laplace transform of e to the power minus bt? Sorry, I'll take plus bt. Plus bt sine omega t, and Laplace transform of e to the power bt cos omega t. Okay? Can anybody type in the chat? If they have, if you have understood this much, then the question is nothing. Like any problem you can face, answer. Apart from Purushottam, Balaji, and Tom, I would like everybody to be part of this discussion session, because it's a discussion session, not a monotonous lecture. Because from the lecture series of Professor Ram, it's only one way. Professor is teaching, but here you are here to just interact and ask your doubts. So it will be better if you also get involved in this process and try to solve the problems parallelly. So can I get some answer? For omega you can type w in the chat. Okay, Tom and Purushottam have written the omega minus b. This is for sine omega minus b by s square plus omega minus b whole square. This is by, let's tag this. This is by Tom, and Purushottam has written omega divided by s minus b whole square plus omega square. Okay, this is by Purushottam. Okay, so anybody else? Okay, Ritesh has also written same as Purushottam. Okay, Tom, you need to be a little careful, because what I had mentioned, wherever you see s, there you add or subtract. Okay, uh, like here it was s only, that's why it like when we multiplied with e to the power minus 80, it became s minus a. Okay, so but here in sine, in the denominator it's only omega, and in denominator only it has s. Okay, so you had subtracted b from omega, not s. So you need to be a little careful in that. I think you will be, you can answer correctly in, like, for the cos. Tom, can you answer the for cos term? Can you write? Okay, Ritesh has written for cos and it's correct. For cos, it will be s minus b by s minus b whole square plus omega square. Okay, everybody understood how it's happening? Wherever you see s, replace s with s minus a, s minus b, or s plus b, whatever is there. Okay, just note about this, whether it's negative or positive. Okay, so coming back to our question. So this this is a very easy question right now. For cos, we know for cos it is cos t. So 1 by, sorry, s by, again, s by s square plus 1 for cos t. So for e to the power minus 2t cos t, it will be simply s plus 2 divided by s plus 2 whole square plus 1. Yeah, Tom, you are correct for the cos part. So is it clear for everyone? Can I, can, if anybody has some doubt, they can raise their hand or type no in the chat. I'll be happy to explaining again. Or if it's clear, then type yes. Okay, cool. Can I get some more yes so that I can be confirmed that this part is clear? Okay. Okay. So cool. Thank you, everyone. So coming to the next question, which is gonna be kind of the last question of this problem statement, like problem solving session. So uh, I want every one of you to have some pen and paper so that we'll be solving it parallelly. So this is a bit longer problem statement. So it will take some time. So everybody be ready with their pen and paper. Okay. So the question is, okay. The LTI system, I just explained what is an LTI system, and in the whole course, the classical control theory, we will be dealing with LTI system only, linear and time invariant system. So the LTI system governing equation is y double dash of t plus 5y of t, y dash of t plus 4yt is equal to ut. Okay. So the Laplace, okay. First of all, I want to emphasis on, like, you might have understood we are doing the Laplace transform. So can I ask someone to why we are doing Laplace transform? Because it's a very important question. It's like we are just doing it, but you need to ask why. So can somebody raise his hand or her hand and answer why we are doing the Laplace transform? What is the beauty of Laplace transform? Anybody? Okay. I guess nobody wants to answer. It's okay. So let me explain it. There are kind of two types of equations. Okay. One is have one, if I am giving you two types of equation, one is having some humongous y fifth derivative of t plus 3y fourth derivative of t plus something like y double dash of t plus y dash of t is equal to something like 5 or something. Okay, this kind of equation, it's a having fifth ordered differential equation. It's a differential equation. Okay, differential equation. And if I give you some other equation with, like, some kind of s to the power 5 plus 3 uh, s to the power 4 plus s square plus s into something and some is equal to something. Okay, to solve it, this is a algebraic equation. Here to solve this problem, the above problem, what you need to do, you need to integrate everything. Like just to integrate a double derivative y double dash of t having something, it's a literally very difficult. Like you integrate first, then you integrate again. But when you convert it, the problem into algebraic problem statement, then what happens? The problem becomes just algebraic, some addition kind of thing, a square or something. Then you can add, subtract, and divide. Like that becomes algebraic. Two terms, one is differential when you are dealing with some derivatives and all, which is very difficult to solve, and another term is algebraic, which is very easy to solve, just adding something, subtracting something, or dividing something, multiplying something. Adding and multiplying we have been doing from class 1, and integrating and differentiation we are doing from after 10th. So definitely will be easy, the adding and subtraction is easier for us. So what Laplace transform does, Laplace transform converts a differential equation, any differential equation, ODE, ordinary differential equation, to an algebraic equation. So what looks very difficult to solve in differential equation is very easy to solve in Laplace transform using the algebraic transformation. So now what I will do, I will just calculate y of s is equal to 5 divided by this thing. And I know some formula from Laplace transform. Using the inverse Laplace transform, I will be using y of t. I will be getting y of t, and very easy to get. But to solve this fifth order differential equation, I challenge you. It's very difficult to solve. That's why to convert a like differential equation to algebraic equation, to ease our calculation, we use Laplace transform. There are many other reasons also, but this is the very basic reason. That's why you should do Laplace transform. Okay, there are, okay, Aditi had replied, convert time domain to complex domain. But why we need complex domain? Complex domain is not visible, like we cannot imagine. Okay, but it's a correct answer. I'm not denying it's a correct answer, but better answer. Purushottam had differential equation converted to algebraic equation. Very good. So, is it clear why we are doing Laplace transform? In frequency domain analysis, I will be explaining few more interesting things when the course will be going there. Okay. So, now coming back to our question. So, the question is, the equation is given as y double dash of t plus 5y dash of t plus 4y of t is equal to u of t. Okay. So what is the, and let us, it's important this term, consider all initial conditions to be 0, because y dash of t Laplace transform will be having y s into y of s minus y dash of 0 at 0. So let's assume all the initial conditions, y dash of y dot of 0, y of 0, everything as 0. So we'll be ignoring these things. Just y dot of, like, first derivative of y, its Laplace transform is sy of s. Okay, cool. So what will be the Laplace transform? Very simple. Assuming all the initial conditions to be 0. That is very important. This term. Never neglect this term. S square y of s plus 5 y of s plus 4 y of s is equal to u of s. Okay. Let us ignore this part. Now we are not considering this part. Forget. I'll just, okay, what is the step input and all? Just take now as u of t. Okay. Then I can write s square plus 5, sorry, here I have missed an s, pardon, 5s plus 4 whole y of s is equal to u of s. So what, well, like if I take y of s, u of s is equal to 1 by s square plus 5s plus 4. Is it correct? Okay. This is called transfer function. You will be learning about transfer function in week 2. Maybe in the next online discussion session, I will be explaining that part. So now come to this which I had striked out. Now the input. What is the input? The input is a step input. So what's the step input? For step input u of t, the Laplace will be 1 by s. So then I can write my y of s is equal to 1 by s into 1 by s square plus 5s plus 4. Okay. I'll just copy this part, copy and paste it here. Okay. Now let's try to solve it parallelly. Okay. You have your pen and paper and I have this 1 by s into, if I divide this, s plus 4 into s plus 1. Okay. So you might know the partial fraction. So I can write this 1 by s into 1 by s plus 4 into 1 by s plus 1 as a divided by s plus b divided by s plus 4 plus c divided by s plus 1. Okay. Okay, you guys calculate the a, b, c. I already have my solutions here. So just calculate it and tell me. I will be solving it later for those who don't know the partial fraction. But before that, I want you guys to be involved. So please, I'll be waiting for 2-3 minutes. It's 3:40, 6:40. So I'll be waiting till 6:42. No pressure. If you don't know how to solve it, also it's fine. I'll be explaining that. But I want some answers from the audience. Otherwise, this class will be totally monotonous. I will be only I am speaking. Okay. Tom has answered. Okay. Okay. I'll give like Tom's answer. Okay. I'll give some other color, black maybe. Tom's answer is A is equal to 1 by 4, B is equal to 1 by 12, C is equal to minus 1 by 3. Anyone else? I'll wait for 1 more minute. Then I'll be solving. And okay, Balaji has also got the same, and I can write Balaji also same answer. Anybody gets some other answer? Okay, it's 6:42. I'll be solving the question parallelly. Okay. Uh, okay. So if you have solved the question, if you haven't solved, just go parallel with me. So here we can check a into s plus 4. Sorry, here 1 divided by s into s plus 4 into s plus 1 is equal to a into s plus 4 into s plus 1 plus b into s into s plus 1 plus c into s plus 4 into s whole divided by s into s plus 4 into s plus 1. So I can write a into s plus 4 into s plus 1 plus b into s into s plus 1 plus c into s plus 4 into s is equal to 1. So solving it, I will be getting the exact answer what Tom and Balaji has got. So the solution will be y dash of s is equal to 1 by 4s minus 1 by 3s plus 1 minus 1 by 12s plus 4. Okay. So I had mentioned you the Laplace transform. Okay. Now it's a interesting part. You remember what I have mentioned in the class? If the Laplace transform of f of t is f of s and the Laplace transform of e to the power minus at f of t is f of s plus a, here you can see some kind of constant terms added over here, just like this structure. So I can write the inverse Laplace transform. If I apply, this term doesn't have any additional constant term added to it. So if I just write the y of t, which is the inverse Laplace transform, then the constant term 1 by 4 will be there. As here there is no additional term added, it will be simply as f of t. So, and we remember the Laplace transform of u of t or is equal to Laplace transform of 1 is equal to 1 by s. So simply this will be into 1 minus 1 by 3 into, look, here there is a plus 1 term. So a is equal to 1 here. So 1 by 3 into e to the power minus t into 1. This is f of u of t minus 1 by 12 into e to the power minus 40 into 1. So, so our solution is y of t. This is our solution. That's why, and if there is a question that in the assignment, if you have solved, there are similar questions. What happens when t is equal to infinity? So when t becomes infinity, just put y of infinity, which will be 1 by 4 into 1. This term doesn't have any dependence on time, minus 1 by 3 e to the power minus infinity minus 1 by 12 e to the power minus 4 infinity. So these terms will be going to 0, will be going to 0. So what we'll have 1 by 4. So I think this this kind of problem which is in your assignment 1 will can be solved very easily by you. So any more questions? Is it clear? Can you type in the chat whether this is clear or not? Yes or no, please. If the question is not clear, then I can explain it again. Okay, very good. Thank you, Balaji and Aditi. John, is it clear? I didn't get confirmation from you. Okay, thank you, Sunita. So these are the 5 questions I wanted to solve. So few of you guys had joined late, so I'll just brief from the starting what I had uh, discussed. First, I discussed LTI system. What is the LTI system? You can remember, it's a combination of linear and time invariant system. So linear system is of 2 types. One is like it should satisfy 2 properties. One is homogeneous property and another is superposition property. In this whole and time invariant, so in the whole course, this control system course, you will be dealing with LTI systems only. You will not go to the non-linear system or time varying system. Okay. So then I explained what is the homogeneous property, and then I explained if this kind of systems do look it's linear system, but this is not a linear system, it's a affine system. I hadn't mentioned the term. You need not worry about the term affine because this is not part of this syllabus. So this is not linear system. Rather, if the system passes through origin, then only it can be called a linear system. So if you have missed the lecture, then I will be providing you the like my YouTube link. You can check in the YouTube link. I'll be updating the video in that. Then I explained this question, and then in the second question also linear question, then some few numerical questions. Now the floor is open. If anybody wants to ask something, some doubt regarding the course or anything, you can ask. Otherwise, the I won't be solving any more problem. If you want, you can leave. You can type the question if you and or you can directly ask. I guess this lecture is clear to you and have solved some doubts. How to identify a time varying or invariant equation? Okay. What the name itself is self-explanatory. Time varying and time invariant system. Okay. So what happens? Suppose this is my system. I am giving x of t and I am getting some output y of t. It doesn't matter. So like what x I am giving and what y I am getting out. So it doesn't matter. Just take x and so what happens when I delay the system? So instead of starting from, if this is my plot, this is time and this is x of t. So at time 0, let's assume my x of t is a unit step. So I'm giving like this. Okay. And let us assume my system behaves, my y of t is like when you give some input, so it behave like this. It can behave anything, just assume for now. So what happens when I delay the system? Instead of starting at, sorry, instead of starting from t is equal to 0, I delay the system and I liked it. That's why I'll just t is equal to 5. I'll just start the system at t is equal to 5 instead of t is equal to 0. So what happens if my system behaves exactly the same like this? Just the output is delayed up delayed in that period. So if my input is x of t minus tau, my output is exactly y of t minus tau. It doesn't have any other term. It's exactly the same, just delayed. Like मैं अभी start करने के अलावा अगले साल start करा. Okay, that kind of thing. Then it can be called a time invariant, because it can be called time invariant because when I delay the system, delay the input, the system didn't give any other output. Okay, but if the why this term is not satisfied, there are some other term, like in the first question, the first problem, it had t u of t. So when I delay the system, I make the system as u of t minus tau. The output will be t into u of t minus tau, u of t minus tau. But this is not equal to t minus tau into u of t minus tau, which is y of t minus tau. Okay, is it clear, or I need to explain it again? Aditi, you had asked. Yeah, thank you. Any more doubt? Okay, thank you, Balaji. No doubt. And Saurav, shortcut method of linear time LT using time dependence, like T. Yeah, like if there is a term T multiplied in the system, na, it is definitely gonna be time dependent. Okay. So I'll be just dropping my YouTube link so that if somebody has joined late, they can check the lecture later anytime. So I have recorded the lecture. So just 1 second. So this is my YouTube channel link. So you can go through the lecture in maybe 2 days. So I'll be uploading within 2 days, and I'll try to upload it by tonight only. So you can go through this later if you had some doubt or you want to be understand the concepts again. So you can go through it anytime. And this is my mail ID, what I had mentioned initially, and I will type it again so that if you have any doubt in midweek, if just reach me out. I'll try to help if I'm not busy. Otherwise, I will address the question in the next session. And mark this Zoom link which I have given. There might be some other time when I will be discussing the question. I had been instructed to shift my time. So, anyways, any link you can join. Okay. So I'll be ending the session right now. If you don't have any questions, thank you. Have a good week ahead. Yeah. And